Good day. Welcome back to yet another session on our YouTube channel. So today we are on solving the question Newton's laws questions. So let's just see how everything goes. So we are answering all the questions that are on this. So this question has 19 marks. So let's see how we can totalize all these marks step by step. So at first, let's read the statement. Let's take out the important information from the statement. So a block of mass 2 kg resting on a raft. So on a raft, so already we know that there is frictional force. So let's just write that down. Horizontal table is connected by a light inextensible string passing over a frictionless pulley to another block of mass 5 kg. So already you can see that there will be tension there. So these are the block. We can see that we are having Fg as well, and also this we have Fg, and it is also on a surface, so it will have the normal force. So let's not forget the frictional force since it is on a rough surface. So a force of 40 newtons is applied to the block of mass 2 kg at an angle of 15 degrees to the horizontal, causing the block to accelerate to the right. So now the blocks are accelerating to the right. This is the direction of motion. The coefficient of kinetic friction between the table and the block is 0.45. So this is the coefficient. We show the coefficient by that. So that is the coefficient of kinetic friction. Ignore the effects of air friction. Okay, so the first question is define normal force in words. So let's just write it maybe somewhere there. 4.1. So what is normal force? Normal force, this is the force that the surface exerts on the object it is in contact with. So this is the force the surface exerts on the object it is in contact with, and it is always perpendicular. So it is perpendicular upwards from the surface. So this is perpendicular upwards from the surface. So this is the force that the surface exerts on the object it is in contact with, and it is always perpendicular upwards from the surface. So that's the first question, and you can get your 2 marks there. The second question, draw a labeled free body diagram showing all the forces acting on the 2 kg block. So let's just draw our free body diagram, because already we know all the forces that are acting on this block. So this is our object, and we're having the normal force. Sorry about that. So we're having the normal force, we're having the tension. So this is our normal force, we're having the tension, and we're having the force that is applied at an angle. So this is the force that is applied. Since this object is moving to the right, so it means that we are also having the frictional force moving to the left, and we are also having the gravitational force. So this is 5 marks. So 5 forces will do 1, 2, 3, 4, 5 forces, just like that. So the other question is like calculate the magnitude of the normal force acting on the 2 kg block. So this is question 4.2. So let's move to 4.3. So now what should you do if you are trying to calculate the normal force? As you can see, this is our free body diagram. So first you need to consider the upwards motion, because you can see that the normal force, it is going upwards. You can see that. So we need to consider the upward motion. So this object is having, it doesn't have the upward motion, which means that the acceleration going upwards, it is 0. So the acceleration upwards, it is equals to 0. So how many forces are acting upwards and downwards? So let's see. So let's draw another diagram to illustrate the upwards motion. So we can see that we're having the force applied like that. So this force, it will have two components. It will have the F at x and it will have the F at y. So it means that upwards we're having two forces that are going upwards and also the normal force, and downwards we are only having one force, which is Fg. So to calculate the normal force now, it means that we must add these forces, and the acceleration is 0 since it is not having the upwards and downwards motion. So we can start with our F net is equals to ma, but since acceleration going upwards, it is 0, it will be like that. So let's see how many forces are acting up and down. There are 3 forces. So this means that our F at y plus our normal force plus our Fg must give us 0, like that. So now let's see what else do we have. How to calculate Fy? F at y, this is the same thing as F sine of theta plus our normal force, which is also going upwards, so it is positive, but our Fg is going downwards, so it should be negative. So this should be plus negative. And how do you calculate Fg? Fg we calculate using mg, the mass times the gravitational acceleration. So mg is equals to 0, right? So what else do we know? We know that this force, it is 40 newtons. So 40 multiplied by the sine of the angle there, it is 15, plus the normal force minus the mass, which is 2, gravitational acceleration, which is 9.8, should give us 0. So now we can make normal force the subject of the formula, which should be this going that side, it will be positive. So 2 times 9.8, it is 19.6, subtracting 40 sine of 15. So now this makes our normal force to be 9.25 newtons, which is upwards, just like that. So this is our 4.3. So let's go to 4.4 now. So 4.4 is saying calculate the kinetic frictional force. So the kinetic frictional force, this is Fk, and this is given by the coefficient of kinetic friction multiplied by the normal force. So the coefficient of kinetic friction were given as 0.45 multiplied by the normal force, which we just found as 9.25 newtons. So multiplying this together, we can get that our kinetic friction becomes 4.16 newtons, like that. So the last question is calculating the acceleration. So calculating the acceleration can be a bit difficult since we don't know what is the tension. So it means that now in this situation we can use both blocks to try to calculate the tension as well as the acceleration. What we just have to know is that when blocks are moving together, they will have the same acceleration. So acceleration must be the same, and also tension is also the same, just opposite in directions. So now let's see, let's formulate our equations here and then we can solve them there. So starting on this block, the 2 kg block, we know that our F net is equivalent to mass by acceleration. So this object, if you can check, it is having the F at x here, since we're having the force that is being applied at an angle, to have F at x, it will have frictional force, and it will also have the tension, like that. So these are the 3 forces that are acting parallel to motion. So now it means that our tension plus our frictional force plus our F at x must be equivalent to mass by acceleration. So now this means that our tension plus, since frictional force is going the opposite direction, it should be negative frictional force plus negative F at x, since it is going in the opposite direction, this should be giving us MA. So F at x, how do you calculate F at x? We know that F at x, it is calculated using F of x is equals to F cos of theta. So this means that our tension plus and minus, it will give us negative, and our frictional force we have already calculated as 4.16, and then minus F at x, which is 40 cos of 15, will be equivalent to the mass, which is 2 multiplied by the acceleration. So this is our equation 1. Let's just copy it down there. So found that our T minus 4.16 minus 40 cos of 15 is equivalent to 2A. So we can take everything that other side, which makes our tension equivalent to 2A plus 4.16 plus 40 cos of 15. So after multiplying, after adding this together, we can see that this is 2A plus 42.80. So this is our equation 1. So now let's check this other object. So this other object, we can see that there are only 2 forces that are acting with motion on this object. So we can see that we're only having the tension and the Fg. So we can write that the equation F net is equivalent to mass by acceleration. So which on F net, we can see that we're having Fg plus tension is equivalent to mass by acceleration. So our Fg, we calculate Fg using mass times gravitational acceleration. So this is 5 by 9.8. Since tension is going in the opposite direction, so it should be negative. So minus tension will be equivalent to 5 acceleration, like that. So now let's check that equation and write it there. So here we can see that we're having 5 by 9.8 minus tension is equivalent to 5 by acceleration. So let's rearrange, taking t that side and 5a this side. So now 5 multiplied by 9.8 will give us 49. So 49 minus 5a will be equivalent to tension. So this can be our equation 2. So now we're having 2 equations that we can solve simultaneously to get our acceleration. So we can just equate, since this is starting with t, this is also starting with t, so we can equate. So our 2a plus 42.80 becomes 49 minus 5 acceleration. So taking this that side and this to this other side, 2a plus 5a gives us 7a, being equivalent to 49 minus 42.80, which is 6.20. Now we can divide by 7 throughout, so acceleration will be equivalent to 0.89 meters per square second. Right. So this is how you were supposed to answer this question. So I hope you have gained something on this. So if you have enjoyed and gained, please show by liking, commenting, and also subscribing. Please comment whatsoever that you feel like you can improve or that you can feel like we are doing great. Have a lovely day.